The National Electrical Code, or NEC, addresses the use of flexible whips in section 400.8. Flexible whips not exceeding 6 feet in length may be used for temporary installations, such as for appliances or machinery. Flexible whips not exceeding 18 inches in length shall be permitted for pendants, fixtures, and other utilization equipment where the equipment is fastened in place, except for in hazardous classified locations. Mounting receptacles on pedestals or racks would be considered a permanent installation. Therefore, the use of flexible whips would not be permitted according to the NEC. To resolve the challenge, consider the following alternatives. Firstly, install a conduit system under the raised floor to route the circuits to the receptacles, as this provides a more permanent and organized solution. Secondly, use a wireway system to contain the circuits and provide a more orderly appearance. Thirdly, purchase pedestals that have integrated circuits, eliminating the need for flexible whips. Fourthly, install the pedestals in a way that allows the circuits to be routed under the floor with only a short flexible whip, less than 18 inches, connecting to the receptacle. Ensure that the flexible whips used meet the plenum rating requirements for the data center. Secure the flexible whips properly to prevent disconnection. Label the circuits clearly for easy identification. Given the concerns raised by the code and the challenges with flexible whips, it is recommended that the alternative solutions listed above are explored. These options will provide a more permanent and orderly installation that meets the code requirements. A conduit system offers a robust and reliable method for routing electrical circuits. It provides physical protection to the conductors, shielding them from damage and environmental factors. When installing a conduit system, several factors must be considered. Firstly, the type of conduit. Secondly, the size of the conduit. Thirdly, the support and securement of the conduit. And fourthly, the proper grounding and bonding of the conduit system. Different types of conduit are available, each suited for specific applications. Rigid metal conduit, or RMC, is a heavy-duty option that provides excellent protection against physical damage and is suitable for both indoor and outdoor use. Intermediate metal conduit, or IMC, is a lighter weight alternative to RMC, offering similar protection at a lower cost. Electrical metallic tubing, or EMT, is a thin-walled conduit commonly used for indoor applications where physical protection requirements are less stringent. Flexible metal conduit, or FMC, is a flexible option that allows for bends and offsets in the conduit run, making it suitable for connecting to equipment that may be subject to vibration or movement. The size of the conduit must be appropriate for the number and size of conductors being installed. The National Electrical Code, or NEC, provides tables that specify the maximum number of conductors allowed in different sizes of conduit. These tables take into account the conductor size, insulation type, and conduit fill percentage. Proper support and securement of the conduit system is essential to ensure its stability and prevent damage. Conduit must be supported at intervals specified by the NEC, typically every 10 feet for a rigid metal conduit and every 3 feet for electrical metallic tubing. Conduit supports such as straps, clamps, and hangers should be properly sized and installed to securely hold the conduit in place. Grounding and bonding of the conduit system is critical for electrical safety. The conduit system must be properly grounded to provide a low impedance path for fault currents, minimizing the risk of electric shock. Bonding jumpers should be used to connect sections of conduit together into equipment grounding conductors. A wireway system is another alternative for containing and routing electrical circuits. Wireways are metal troughs or enclosures that provide a protected pathway for conductors. They are typically used in industrial and commercial applications where a large number of conductors need to be routed in an organized manner. Wireways offer several advantages. Firstly, flexibility. Secondly, accessibility. And thirdly, ease of installation. Wireways can be easily modified and expanded to accommodate changing needs. Conductors can be added or removed from the wireway without disrupting the entire system. Wireways provide easy access to conductors for maintenance and troubleshooting. The hinged covers or removable panels allow for quick inspection and repair. Wireways are relatively easy to install compared to conduit systems. They can be mounted directly to walls or ceilings using brackets or hangers. Several types of wireways are available, each suited for specific applications. NEMA 1 wireways are general-purpose wireways for indoor use. NEMA 3R wireways are suitable for outdoor use, providing protection against rain, sleet, and snow. NEMA 12 wireways are designed for industrial applications, providing protection against dust, dirt, and dripping non-corrosive liquids. When selecting a wireway system, several factors must be considered. Firstly, the size of the wireway. Secondly, the type of enclosure. And thirdly, the support and securement of the wireway. The size of the wireway must be appropriate for the number and size of conductors being installed. The NEC provides guidelines for determining the appropriate wireway size based on conductor fill. The type of enclosure should be selected based on the environmental conditions. NEMA 1 enclosures are suitable for indoor use, while NEMA 3R and NEMA 12 enclosures are designed for outdoor or industrial environments. Proper support and securement of the wireway is essential to ensure its stability and prevent damage. Wireways should be supported at intervals recommended by the manufacturer, typically every 5 to 10 feet. Pedestals with integrated circuits offer a convenient and aesthetically pleasing solution for providing power to equipment. These pedestals typically house receptacles, circuit breakers, and other electrical components, eliminating the need for flexible whips or other exposed wiring. Pedestals with integrated circuits are commonly used in data centers, offices, and other commercial environments. They offer several advantages. Firstly, clean aesthetics. Secondly, improved safety. And thirdly, ease of installation. Pedestals conceal wiring and electrical components, creating a clean and organized appearance. They eliminate the need for exposed wiring, reducing the risk of tripping hazards and electrical shock. Pedestals are relatively easy to install compared to conduit or wireway systems. They can be easily moved or reconfigured as needed. When selecting pedestals with integrated circuits, several factors must be considered. Firstly, the height of the pedestal. Secondly, the number and type of receptacles. And thirdly, the circuit breaker capacity. The height of the pedestal should be appropriate for the equipment being powered. Pedestals are available in various heights to accommodate different applications. The number and type of receptacle should be selected based on the power requirements of the equipment. Pedestals can be configured with various combinations of standard receptacles, surge-protected receptacles, and USB charging ports. The circuit breaker capacity should be sufficient to handle the load of the equipment being powered. Pedestals typically include circuit breakers to protect against overloads and short circuits. Installing pedestals in a way that allows the circuits to be routed under the floor with only a short flexible whip, less than 18 inches, connecting to the receptacle is another option that complies with the NEC. This approach combines the benefits of both a permanent wiring system and a short, flexible connection to the equipment. When using this approach, it is important to firstly ensure that the underfloor space is suitable for running electrical circuits. Secondly, use appropriate wiring methods and materials. And thirdly, properly secure and protect the flexible whip. The underfloor space should be clean, dry, and free of obstructions. It should also be adequately ventilated to prevent overheating. The wiring methods and materials used should comply with the NEC requirements for underfloor installations. This may include using plenum-rated cables and conduit. The flexible whip should be properly secured to both the pedestal and the receptacle to prevent strain and disconnection. It should also be protected from physical damage. Regardless of the wiring method used, it is essential to ensure that all flexible whips meet the plenum rating requirements for the data center. Plenum-rated cables are designed to be used in air handling spaces, such as the space above a suspended ceiling or under a raised floor. These cables are made with materials that produce minimal smoke and toxic fumes in the event of a fire, reducing the risk of harm to occupants. Secure the flexible whips properly to prevent disconnection. This can be accomplished by using strain relief connectors, cable ties, or other appropriate methods. Properly secured flexible whips will prevent accidental disconnections, which can lead to equipment downtime and safety hazards. Label the circuits clearly for easy identification. This will make it easier to troubleshoot problems and perform maintenance in the future. Circuit labels should include the circuit number, the equipment being powered, and the voltage and amperage of the circuit. It is important to consult with a qualified electrical contractor to ensure that the electrical installation meets all applicable codes and regulations. An electrical contractor can assess the specific needs of the data center and recommend the most appropriate wiring methods and materials. They can also perform the installation and ensure that it is done safely and correctly. In summary, flexible widths are permitted for temporary installations but not for permanent installations, such as mounting receptacles on pedestals or racks. Alternative solutions include conduit systems, wireway systems, pedestals with integrated circuits, and installing pedestals with short flexible widths. Ensure that all flexible widths meet the plenum rating requirements, are properly secured, and the circuits are clearly labeled. Consult with a qualified electrical contractor to ensure compliance with all applicable codes and regulations. Section 400.8 of the NEC provides specific guidelines on the uses permitted and not permitted for flexible cords and cables. Understanding these guidelines is crucial for ensuring electrical safety and compliance with code requirements. Some of the permitted uses include pendants, wiring of fixtures, connection of portable lamps and appliances, elevator cables, wiring of cranes and hoists, connection of stationary equipment to facilitate their frequent interchange, prevention of the transmission of noise or vibration, appliances where the fastening means and mechanical connections are designed to permit removal for maintenance and repair, data processing cables as permitted by Section 645.5, connection of moving parts and temporary wiring as permitted in Sections 527.4 and 590.4. Section 400.8 also lists uses not permitted for flexible cords and cables. These include as a substitute for the fixed wiring of a structure, were run through holes in walls, structural ceilings, suspended ceilings, drop ceilings, or floors, where run through doorways, windows, or similar openings, where attached to building surfaces, where concealed behind building walls, structural ceilings, suspended ceilings, drop ceilings, or floors, unless specifically permitted by other sections of the NEC, where installed in raceways, except as otherwise permitted in the NEC. The length limitations on flexible cords and cables are dependent on the specific application. As previously mentioned, flexible widths not exceeding 6 feet in length may be used for temporary installations. For permanent installations, flexible widths not exceeding 18 inches in length are permitted for pendants, fixtures, and other utilization equipment where the equipment is fastened in place, except for in hazardous classified locations. The type of flexible cord or cable used must be appropriate for the application and environment. Factors to consider include the voltage and amperage rating, the temperature rating, the resistance to moisture, chemicals, and abrasion, and the suitability for use in wet or dry locations. Flexible cords and cables must be properly supported and secured to prevent strain on the connections and to protect them from physical damage. Support should be spaced according to the manufacturer's recommendations and the requirements of the NEC. Flexible cords and cables should be protected from physical damage by routing them away from sharp edges, heat sources, and other potential hazards. Strain relief connectors should be used at the point where the cord or cable enters the equipment or enclosure to prevent strain on the connections. Grounding and bonding are essential for electrical safety. Flexible cords and cables used to connect equipment must be properly grounded or double insulated to prevent electric shock. Grounding conductors should be sized according to the requirements of the NEC and should be securely connected to the equipment grounding terminal. The NEC contains specific requirements for the installation of electrical wiring in data centers. These requirements are designed to ensure the safety and reliability of the electrical system in this critical environment. Some of the key requirements include the use of plenum-rated cables in air handling spaces, the installation of a separate grounding system for electronic equipment, the provision of adequate ventilation and cooling to prevent overheating, and the use of uninterruptible power supplies or UPS systems to ensure continuous power in the event of a power outage. Section 645 of the NEC covers information technology equipment and provides specific requirements for wiring in computer rooms. This section addresses issues such as disconnecting means, grounding, cabling under raised floors, and the use of flexible cords and cables. Section 645.5 specifically addresses flexible cords and cables and permits their use under certain conditions. The flexible cords and cables must be listed for the purpose, the length must not exceed 15 feet, the cords and cables must be protected from physical damage, and the cords and cables must be installed in accordance with the manufacturer's instructions. In addition to the NEC, other codes and standards may apply to electrical installations in data centers. These may include local building codes, fire codes, and industry standards such as those developed by the Telecommunications Industry Association or TIA. It is important to consult with the local authorities and industry experts to ensure compliance with all applicable codes and standards. Ignoring the NEC can have serious consequences, including electrical shock, fire, and equipment damage. Compliance with the NEC is essential for ensuring the safety of people and property. Failure to comply with the NEC can also result in fines, penalties, and legal liability. By following the guidelines and requirements outlined in the NEC, you can ensure that your electrical installations are safe, reliable, and compliant with code requirements. This will help to protect people, property, and equipment from the hazards of electricity.